Okay, so today we'll be doing question number 6 on page 49. In the givens, we know that the displacement is 220 kilometers north. The velocity of the air to the ground is 42 kilometers per hour north, 30 degrees east, and the velocity of the plane to the air is 230 kilometers per hour. In this first part, we're trying to solve for the direction of the velocity of the plane to the air. So, first we're going to draw the vectors. So the first vector we're going to draw is the velocity of the air to the ground, which is 42 kilometers per hour at a bearing of north 36 degrees east. And then you know that the resultant vector of the plane to the ground is some magnitude directly north. And then you're trying to solve for the direction of the velocity of the air to the ground, of the plane to the air. So that's 230 kilometers per hour for the magnitude. First, we're going to solve for theta, which is up here, so we can find this angle here, and we'll call that alpha. So using sine law, we can solve for theta. So sine theta over 42 equals sine 36 over 230. Theta turns out to be 6.16 degrees. Okay, and then using the interior angles of the triangle theorem, you can solve for alpha. So alpha equals 180 minus 36 minus 6.16 degrees, and you get 137.83 degrees. So in order to find the actual bearing of the velocity of the air of the plane to the air, you're going to take 137.83 subtract 54 degrees. You subtract 54 degrees because of the parallel angle theorem. You know that 54 is here, so then you also have 54 up there. And then if you subtract 54 from that, you get this angle right here. So you end up with 83.84 degrees. So you could write that as west 83.84 degrees, or as it says in the textbook, north 6.16 degrees west. This should be west 83.84 degrees north. So that's part A. In part B, you want to find the time. So, again, we're going to draw the vectors. So we know that this is 42, this one is 230, and then you want to find the velocity of the plane to the ground. So we know the angles inside. This is 6.16, this is 36 degrees, and then this is 137.8. So now we're going to use sine law to find the magnitude of the velocity of the plane to the ground. So that's over sine 137.8 equals, look, we can say 42 over sine 6.16. So the magnitude of the velocity for the plane to the ground becomes 262.65 kilometers per hour. And we know that the direction of it is due north. So now that we know that, we are going to solve for time. So velocity of the plane to the ground is 262.65 kilometers per hour north. And then delta D equals VT. So T equals delta D over V. So sub in the values for delta D and V, which is 220 over 262.65, and then T turns out to be 0.84 hours, and that's the end.